Okay, functions, welcome back. Still kind of into our trig unit after a week off, and let's get right into it. We're going to talk about circular motion today. All right. There's two ways we measure circular motion. We can measure it based on the arc length, or we can measure it based on the angle. Okay, and we'll talk about each of those today a little bit. So arc length can be used to analyze circular motion, which is an object moving along a circular path. Okay. Like I said, there's two ways we measure it. One is linear speed, which is the rate at which the object moves along the circular path. Really, it's the rate at which it travels around the arc length. Okay. Remember, the arc length was S. It was our outer rim. It's the crust of the pizza. Okay. So how long does it take to travel around that outer ring? Okay. So it's a linear speed, even though it's a circular object or circular path. How we find linear speed is how we find most speeds. It's going to be a distance over a time. Okay, like miles per hour. Miles is distance, time is hours of time. All right, so our formula for this is going to use v for velocity, and it's going to equal. It's going to equal s over t. Where again, remember, s is the arc length, and t, of course, is time. Now, one thing to note is that the radius, the actual circle part, doesn't come into play anywhere in here. So the angle doesn't matter. It's only the arc length. Okay. Now, the arc length, to find the arc length, you need the angle. So it does come in, but it's not part of the formula. So it's just the arc length divided by time. Okay. So the arc length is going to be some distance, and time is going to be, per second, per minute, per hour. The angular speed, or the rotational speed, is the rate at which the central angle changes along the path. Okay. So the formula for angular speed, pretty similar to the linear speed, but now we're going to use the angle part. So instead of v for the angular speed, we use the lowercase omega, which is just a curvy w. And that's going to equal theta, which remember is the central angle in radians, divided by time. So if you have a linear speed, you're going arc length over time. If you want angular speed, you're doing central angle over time. Now again, just like before, the angle, the central angle, theta, has to be in radians. Okay. So if you're given something in degrees, we're going to have to convert it to radians. So again, the linear speed is a distance per time, whereas the angular speed is a revolutions per time. It's how many times does it rotate in a certain amount of time. All right, so let's do one of each. A bicycle tire with a radius of 14 inches rotates at a rate of 125 revolutions per minute. Okay. So every minute, your bike tire is going to rotate 125 times. Okay. And the distance, the radius of that bike tire is 14 inches. Okay. So we're going to find out, first we're going to find out the linear speed in inches per minute. Okay. So if you were to just let that bike tire roll for, 1 full minute, it's going to rotate 125 revolutions, but we want to know how far is it going to go. All right, well, the first thing we need to do is we need to find the arc length. Okay? Because remember, the formula is arc length over time. We know the time is just going to be 1 minute, but we don't know what the arc length is. So we're going to start by finding S. All right, remember, to find the arc length, you have to do the angle times the radius. So radius times theta. Now we know the radius is 14, but what's theta? Okay. Well, we're talking about it in revolutions per minute, so it's making a full trip around the circle 125 times. So your theta in here is going to be 2 pi. Because remember, it's 2 pi all the way around a circle. Okay. But it's not just going once around a circle, it's going 125 times around the circle. So we're going to have to do 2 pi times 125. Now again, those parentheses don't mean anything. I just want to show that, the 14 is the radius part, and the 2 pi times 125 is the theta part. All right, that's going to tell us the arc length, which is going to be 14 times 2 times 125, which is 3,500 pi. Which again, it doesn't really mean anything to us, so we're going to convert that to radian, or to just normal. We're going to do 3,500 times 3.14, which will give us 10,996 inches. So that's how far it goes in 1 minute. Okay. Now to write it as a linear speed, it's just going to be that distance. Okay, the arc length, which we just found, 10,996 inches. And it was traveling that far in 1 minute. So anything divided by itself is just 1, or it's just itself. So we're going to say this goes 10,996 inches per minute. All right, so that's a linear, the distance it traveled in a minute. Now I want to figure out how, what angle is changing per minute. The angular speed in radians per minute. All right, now this one, for the formula, we only need to know what theta is. Okay, and luckily we just found theta. We already figured out theta to find the linear speed. So we're just going to do that again. Theta is going to be equal to 2 pi, which is all the way around the circle, times how many times does it go all the way around a circle? So it's going to be 2 pi times 125 revolutions per minute. Which is going to be 250 pi radians. All right, and then plug it into the formula. Again, you could change the pi out right now, or you could do it later. We'll do it later on this one. So omega, the angular speed, is going to equal 250 pi radians per minute over 1 minute. So 250 divided by 1 is just 250. 250 times pi is 785 radians per minute. So that's how quickly that's how many angles, how many radians in a minute that the bike tire is going around. Which corresponds to 125 revolutions per minute. All right, I'm going to do example 2 in a different video, 2 and 3 in a different video. This will take care of the homework problem 1, if you want to get started on that.